Hi everyone, it is getting to be that time of the year once again, time for the winter 2015-2016 forecast, and we have a lot to talk about, which is why this will be split into multiple videos to cover both the seasonal model forecast and the observations. We might have to split it into 3 videos depending on how long each section goes. So first, taking a look at the sea surface temperature analog model, you can see that we have a very classic looking low right by the Aleutians, which is what you would typically expect for an El Nino. And what is really interesting about this model is it takes previous years that are similar to this year with sea surface temperatures and makes a composite out of them to produce a 500 millibar height composite. And this model also takes years that are dissimilar, years that are the most dissimilar to this year, and then flips the sign, also factoring them into an account, and we get this particular depiction. A very strong Aleutian low, a West Canadian ridge, and a southeast trough. This West Canadian ridge is going to be very crucial for how this winter will turn out. If this is further southeast, this trough will be further suppressed, and you'll see a warmer winter. If this West Canadian ridge is further northwest, however, this trough will be allowed to expand. You'll be dealing with a colder winter than what is currently being forecasted by most outlets. This is also a crucial feature, the Aleutian low, and this will be determined by where the best upward motion will set up in the tropical Pacific. We can get a rough approximation as to where the best upward motion will be from precipitation, actually. And you can see that the best precipitation is centered right around the date line. And precipitation is a good proxy for this because we can use upward motion to determine where the clouds will set up and therefore where the best precipitation will set up. This particular model has it setting up right around the date line, which would be fairly far west and would support an Aleutian low west of the West Canada. And the further east-based years, the years that had the best upward motion in the tropical Pacific further east, had this Aleutian low on the west shore of Canada. So this is going to be very crucial in determining where exactly the Aleutian low will set up. What's remarkable, though, is that most models do have it centered right around the date line. I'll be showing that very shortly. So you can see what's really interesting is that according to this model, for December, we will be dealing with a more basin-wide look to the El Nino, along with the horseshoe of warmer than normal water in the northern Pacific, the classic positive precipitocadal oscillation signature, which persists into February. But notice what happens is that it goes from more of a basin-wide state to more of a west-based state into February. And this is crucial because a west-based state would favor more cold and snow into the southern and eastern portion of the United States as opposed to a basin-wide El Nino. So this alone suggests that we could be dealing with a backloaded winter or a winter with more cold and snow in the second half than in the first half. This is the NMME. This is the North American model ensemble. You can see that it has only 2 areas of below normal heights at 200 millibars. It has one in the central U.S. and it has one with the Aleutian low. You can see it's actually in very good agreement with the sea surface temperature analog model, focusing that ridge into northwest Canada, and that's very crucial because that allows for the trough to respond in the central U.S. as a result. What's also really interesting is it has the best upward motion, the best precipitation right around the date line, which would support the best upward motion setting up right around the date line once again, consistent with the sea surface temperature analog model. This is the Jamstick model. This is the Japanese model, and you can see it's also in agreement. It has the best upward motion setting up right around between 150 west and 150 east, right around the date line. And you can see that it sets up a colder southeast, near normal for Pennsylvania into New Jersey, warmer northeast of there, and warmer northwest of there. There is reason to believe that the January, February, March composite would be colder than this, which unfortunately is not available from the Jamstick, and I'll be explaining why in a little bit. So this is the UK Met and the Euro. I can't show the Euro, but I do have access to it, so this is what it looks like roughly. The UK Met and the Euro both show, once again, with the rest of the seasonal guidance, that Aleutian low right here, and it shows the West Canadian ridge This is a persistent feature in every single one of the model ensembles that I have taken a look at, with the exception of the CFSV2, which is also taken into account with the North American model ensemble, however. So you can see that the UK Met has a trough in the southeast US in response to this ridge in northwest Canada, and the Euro also has the same kind of look as well, with a little bit of a trough response into the southeast United States. So most seasonal models are in very good agreement as to where the best upward motion is going to set up, and therefore where the Aleutian Low will set up and where the West Canadian Ridge will set up. But the better question is if this agrees with observations or not. And what's really interesting is that we have a really strong El Nino event that happened in 1940 to 1941 that had a very potent Aleutian Low that is being forecasted by most seasonal models. You can see that West Canadian Ridge response and the response into the southeast U.S. with a trough. Now the better question is, does this agree with the observations? And I will be taking a look at that in a separate video. Thank you for watching.